Hello everyone, this is Prajit and I am welcoming you all on my YouTube channel Math-e-fobia. Today and in the successive classes, we will understand how I will revise the all chapters of class 10 one by one. In this process, in this series, the first chapter, that is real number, we will start from it. First, I will give you all the topics that is very important for this chapter, and in one next video, we will discuss the important questions related to this topic class. The first topic for this chapter is natural number. What we mean by natural number? All the counting numbers. Counting numbers are known as natural number. Why we call natural number as natural? Because the counting is given by God to us, Bhagwan Vidya. So we are able to count whether we are a young one or the older one. We can count easily. So if you want to talk about natural number, the examples you like 1, 2, 3, as you know, all the counting numbers. Similarly, what we mean by whole number, this is just a revision thing, so you have to understand it very well. What is whole number? All the counting numbers along with 0 will be known as whole numbers. Similarly, what we mean by integers here, what is the meaning of integers? All the positive as well as negative of counting numbers is known as integers. All the positive numbers except 0 will be known as positive integers. All the negative of counting number are known as negative integers. Okay. Now what we mean by rational number? A number that can be written in the form of p by q, where p and q both are integers. One more thing that we can say, p and q both are what? Integers. That p and q are co-prime. I will explain the meaning of co-prime. Before that, move to the next topic, that is irrational number. What is the meaning of irrational number here? General definition was a number which cannot be expressed in the form of p by q will be known as irrational number. That is a basic definition which generally used to tell in the class 7 and 8. But now for the 10th standard, we have to understand one concept, that is non-terminating and non-recurring. Recurring is a word which is generally used for repeating. Okay. If you have a number whose decimal expansion is non-terminating and non-repeating, then that number is known as irrational. Similarly, what will be the definition like this in this? That we have specified that non-terminating and non-repeating. So we can say all the numbers whose decimal expansion is terminating, or what we can say terminating and recurring are known as rational. Okay, so we have got two words, that is terminating and recurring. Is it clear? Now, if you have understand these two words, the most important word, important words are prime numbers and composite numbers. What we mean by prime numbers? A number which has exactly two factors, that is 1 and the second one is itself. The example for prime number will be 2, 3, 5, 7, 11, 13 and so on. These are prime numbers which have only two factors, that is 1 and itself, that is 2. For this 1 and itself 3. These are known as what? Prime numbers. Similarly, what we mean by composite number? Composite number is what? A number which has more than two factors. Just like if we say a number that is 4. 4 is a number which has more than two factors, like 1, 2, again is 4. These three factors are of a number 4, that means 4 is a composite number. Now these are the basic introduction to start the chapter. Now I have used the word co-prime in this one. So now we have to understand the meaning of co-prime. Okay, let's start with the topic co-prime, and there is one more word that is known as twin prime. I will explain both. What is the meaning of co-prime? It's two or more number have HCF as 1. Then those number will be known as co-prime. If you are given as 5 and 7, what will be the HCF of these two numbers? That will be 1. That's very easy. But what will be the HCF of 5, 15 and 7? That is also 1. What will be the HCF of 25 and let's say 49? 25 and 49. That is also 1. Now the second topic is twin prime. What we mean by twin prime? Twin primes are those primes. Let me explain one thing. Co-prime doesn't specify the word prime. That means if both the numbers are prime, that is also correct. One number is composite, second number is prime, that is also correct. Both the numbers can be composite also. But in this case, if two primes have a difference of 2, then we can say that those primes will be treated as twin prime. Let's say there is an example 3 and 5. First of all, check whether 3 and 5 both are prime or not. As you can say, 3 and 5 both are primes. Now find the difference of these two numbers. That is 5 minus 3. That is 2. That means these 3 and 5 are twin prime. Why I have explained these things in the starting? The reason is these topics, natural number, whole number, integers, prime, composite, all these things are very important to solve the MCQs in this chapter. Because sometimes you will face a question like, and what is the HCF of two co-prime numbers? Then if you are known with the word co-prime, then only you can answer this question. Okay. So I have explained the basic concept of this chapter. Now I will start the main core thing of this chapter. So we have to start from the name real number. The usual meaning of this is the combination of rational numbers as well as irrational number is known as real number. What is rational number? A number which can be represented in the form of p by q. Also we can say a number whose decimal expansion is terminating. Or what? One more thing you can say, a number whose decimal expansion is non-terminating as well as repeating. But in the case of irrational number, what we can say, irrational numbers are those numbers in which decimal expansions are non-terminating and non-repeating. Okay, the combination of these two will be treated as real number. If you find the square of any number and that square is non-negative, at that time we can say that that is a real number. Let's take an example. Let's say there is a number root over 17. If you score this number, and the result is 17. Is it a non-negative number? The answer is yes. That means this number root 17 was a real number. Similarly, if I write minus 5 square, what will be the answer of this? 25. Is 25 a non-negative number? The answer is yes. That if I say this circle will represent combination of all the numbers combinedly known as natural number. If you add 0 in this, let's say if we add 0 in this, that will become whole number. Okay. Now, if you add negative of counting numbers in this, that will become integer, which is generally represented as z or sometimes I also. Now, the most important topic is the fundamental theorem of arithmetic. What does it state? Let's first read it. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. First of all, let's understand the meaning of this. What it has said, if you have any composite number, I have explained the meaning of prime and composite, so you have to revise that. If I say a composite number, any composite number can be factorized. Let's say if there is a number that is 24. If you start factorizing this will be 2 into 2 into 2 into 3. Now I have factorized 24 into these terms, and all the numbers here 2, 2, 2, and 3, these numbers are prime numbers. Now what it said, this factorization is unique. That means if there are 3 2 and 1 3, this factorization will remain same if you do anything with it. One more thing is here, apart from the order in which the prime factors occur. That means if you start writing like 2 into 2 into 3 into 2, if you place the order of 2 and 3, if you remove this thing, then all the numbers in this factorization will be same, or you can say unique. This theorem is known as fundamental theorem of arithmetic, also known as uniqueness theorem of arithmetic. Okay, after that we have to start two most important topics for this chapter, that is HCF and LCM. First, let's understand the meaning of HCF. Product of the smallest power of each common prime factor in the number is known as HCF. What is the meaning of this? Let's understand it with an example. If you are given with a number that is 15 and the another number is 72, and you have to find out the HCF of 15 and 72. First of all, find the prime factorization of 15, that is 5 into 3. Okay. What is the prime factorization of 72? That means 2 to the power 3 and 3 to the power 2. It has said smallest power of each common prime. First of all, find the common prime. 3, 3. These are the common prime. Which has the smallest power? This one. Then HCF of this will be 3. Similarly, what will be the meaning of LCM? Product of the greatest power of each prime factor involved in the numbers. The word is greatest power of each prime factors. Each prime factors means if you find common factors first of all, that is these two, which one is the greatest one? 3 square. What about these two? You have to write it as it is. So 2 to the power 3 means 8, 3 square means 9, 5, this will be 360. This is how we are going to understand the topic. Now, there is a most important result using HCF and LCM, that is, for any two positive integers a and b, it has been specified that a and b both are positive integers. Then there is a result, that is HCF of AB multiplied by LCM of AB. This will result as product of the given number a and b. Okay, the next theorem is, let P be a prime number. It has been specified that small p is a prime number. If P divides A square, then P divides A, where A is a positive number. That means if there is a prime number P which divides square of any positive number, then that prime will surely divide that positive integer. This is a theorem which we are going to use in the proof of irrational number. Let me explain one thing. The theorem, fundamental theorem of arithmetic, and this theorem, the proof of these theorems are not important for exam. So we are just going to understand the statement of this, and after that we will solve the questions related to that. That's it for the concept basic things. Now we have to solve some basic questions. Those are generally asked in the examination. The first question is, explain why these two numbers are composite numbers. First of all, revise the definition of composite number. If a number has more than two factors. Okay, let's solve this number first of all. If I write 7 into 11 into 13 plus 13, there is 13 which is common. If I take 13 as common, it will be 7 into 11 plus 1, that is 13 into 77 plus 1, 78. If we can express this number as a product of 2, that means this number is not a prime number. Okay? Because prime number has only two factors. First one is 1 and the second one is the number itself, but we can express this number as product of two numbers. That's why this number is not a prime number, hence it is a composite number. Similarly, if you can see that 5 is common in both of these two numbers, both of these two terms. So if you take 5 as common, this will be 7 into 6 into 4 into 3 into 2 into 1 plus 1. Now we can easily say that the product and sum of these number will be a single digit number which is multiplied by 5. Hence we can say that this number is also the product of two numbers. That's why this is not a prime number, hence it is what? A composite. One more question which is generally asked in the examination of 1 or 2 marks, that what is the value of this number? Root over 7 plus 2 under root 10. So there is a concept behind that. Write this 7 plus 2. What we can write root over 10 as? We can write it as 2 into 5. Is it? So try to express this 7 as these two numbers. So can we write 7 as 5 plus 2? Can we? Similarly, 2 is here. Root 2 into 5 can be written as root 2 into root 5. Is it clear? Now 5 can be written as square of root 5. Similarly, 2 can be written as square of root 2. Is it not looking like a square plus b square plus 2ab type? So we can write it as root over root 5 plus root 2 whole square. This square and this root will be cancelled out, and the final result will be root over 5 plus root over 2, and that's our final answer. I hope this is clear to all of you. The most important question from this chapter is prove that this is a irrational number. Let me explain first of all. In this chapter or for a board examination, you just have to find or prove those numbers in which the number which is in the root will be a prime number. Okay, let's say 3, 5, 7, 11, 13. These type of questions are only important for your examination. Okay, so how we are going to prove that? First of all, we will assume that root 3 is a rational number, which is a contrary thing of irrationality. Now, if root 3 is an irrational number, so we can write root 3 as a upon b. A and b are co-prime integers. First of all, both the a and b are co-prime integers. And one more restriction is here, the denominator cannot be equals to 0. On squaring both the sides, root 3 square will be 3, a by b square will be a square b square. Now by cross multiplying b square to LHS, it will be 3b square equals to a square. Now, if we can write a square as a product of 3 and b square, that means 3 is able to divide the number a square, which I have written here. This implies 3 divides a square. Similarly, if 3 divides a square, then we can say that 3 divides a. How we can say that? Just few minutes ago, I have given you one theorem which said that if p is a prime number and p is dividing a square, then p will surely divide a, where a is a positive integer. Here 3 is a prime number, is it? A prime number is dividing a square of a positive number. So that prime number will surely divide that a. Is it clear? Now, if 3 is able to divide the number a, that means we can write a will be a multiple of 3. So we have supposed that let a equals to 3c for some integer c. C is what? An integer. Okay, let's continue that. After that, we have to use the equation number 1, which I have written here. 3b square equals to a square, which I have supposed as equation number 1. Now we have to put the value of a, which has been supposed as 3c. Now I am putting this a equals to 3c in equation number 1. it will become 3b square equals to 3c whole square. This will give you 3b square equals to 9c square, and the final result is here b square equals to 3c square. Again, as you can see that b square can be written as the product of 3 and c square, means two numbers. That means 3 will divide b square. Okay, if 3 is a prime number and dividing a square of positive number, that means that a prime number again will divide that positive number without the square sign. Okay, that is 3 divides b square, so 3 will surely divide b according to that theorem. Okay, 3 is a common factor of a and b. Here we can see that 3 is dividing b and 3 is dividing a also. So 3 is the common factor. But in the starting, I have said that key a and b both are co-primes. This implies that this statement is a contradiction for our assumption. This state our assumption was wrong. Hence, root 3 is an irrational number. Class, let me explain. This is the process in which you can prove root 3, root 5, root 7, root 11, root 13, whatever the question will ask, you can prove all those numbers as irrational number. You just have to follow these process. More question is here, which is generally asked in your examination, that prove that 3 minus 2 root 5 is irrational number. With the same process, we will continue that. First of all, we have to assume that this number is rational. That means we can write 3 minus 2 root 5 as a by b, where same thing, a and b both are co-prime integers. Okay. Now transpose 2 root 5 to the right hand side and a by b to the left hand side. This will be like this: 3 minus a upon b equals to 2 root 5. Solve this: 3b minus a upon b equals to 2 root 5. 2 will be in the denominator, 3b minus a upon 2b, which will be equals to 5. If you multiply any number to the integer, this will be an integer. If you subtract an integer with an integer, the result will be again an integer. Similarly, multiplying 2 in an integer will result as integer. So I have supposed this as c and this as d. These two numbers are again integers. We show that root 5 in the form of c by d. That means root 5 is a rational number according to our assumption. But as we know that root 5 is an irrational number. So this is our contradiction to the supposition. So directly we can say that 3 minus 2 root 5 will be what? An irrational number. Let me clear one thing. This type of question will be asked to you in 1 or 2 marks or maximum in 3 marks, in which you don't have to prove root 5 as irrational number with that lengthy process. Okay. If the question is of prove that root 5 is an irrational number, then you have to follow that process. But for this or this type of all questions, you just have to follow this process, and after this just write, since c by d implies that root 5 is a rational number, but as we know that root 5 is an irrational number, so this is a contradiction. Hence, this is what? An irrational number. Okay. This is all from my side. I hope you like this. Comment also, and if you have any query, write it down. I will try to answer that question. Also subscribe the channel. Thank you and have a